Ellipses are very important shapes when it comes to understanding the orbits of planets and moons and spacecraft. So in this video, we're going to take a look at some of the basics of ellipses that apply to an understanding of orbits and gravity in astronomy. So we start by just taking a look at an ellipse. And an ellipse is basically an oval, similar to a circle, but with some differences. So a circle is all of the points that are the same distance from a center point, and we call that distance the radius. And in an ellipse, we basically have two centers. We don't call them centers, though. We call them focal points. And when we make an ellipse, the ellipse is all of the points where the total distance from the two focal points stays the same. A few definitions for ellipses. Instead of diameters and radiuses, we have a major axis, which is the long distance, and a minor axis, which is that shorter distance. And sometimes we'll cut those in half and talk about a semi-major axis and a semi-minor axis. Now back to the definition of an ellipse. So if we take those two focal points and we draw a line to some point on an ellipse, obviously it's closer to the focal point on the left than it is to the focal point on the right. And if we take a second point and we draw these two lines, here the distance is about the same. So the definition of an ellipse is when the sum of those two distances stays constant. So we drop those lines down here. We can see that even though it's closer, one is smaller and one larger, they are the same distance from those two focal points anywhere on the ellipse. This little animation might give you an idea of this in action. So you can see as we get closer to the blue focal point and farther from the red focal point, those lines change, the red and blue lines change, but the total distance stays the same as we go around the ellipse. One additional concept that's important to understand about ellipses is something we call eccentricity. And eccentricity is basically how stretched out the ellipse is. So if I put up two other examples of ellipses, we can see that the one on the bottom left is very stretched out. We say that has a high eccentricity, and the one that's more circular has a low eccentricity. The lowest eccentricity you can get for an ellipse is a perfect circle.